Section 11.4, the geometrical arrangement of electrons and molecular shape. Here's the objectives. Be able to understand the VSEPR theory. Use this theory to predict the three-dimensional shapes of covalent bonds and identify both the electronic and molecular geometry for simple binary compounds. Alright, so let's talk about this. VSEPR, I usually just call it the VSEPR theory. Stands for valence shell electron pair repulsion theory. Basically what it says is electrons want to get as far apart as possible. So it's good for predicting kind of the geometries of these molecules. Kind of gives us a pretty good idea. It's not perfect, but it's really close. And that's what I said. Electron pairs tend to move as far away as they possibly can. So whether they're in a bond or whether they're unbonded, they try to get as far apart as possible. So let's take a look at a few of these. Let's start with ones that have two pairs or a central atom. So we got beryllium and we've got some chlorine on either side. And beryllium just has two electrons, so we're just talking about single bonds. And these are going to get as far apart as they can. And the farthest apart you can get would be a straight line, would be 180 degrees. So these are going to be 180 degrees apart when they form bonds. Now when they're talking about electronic, they're talking about all of the things including electrons. If there were just extra electrons in here, in this case there isn't. And then if they're talking about molecular shapes, they're talking about what are the atoms. And sometimes in this case they're both the same, but in some cases they won't be. Let's take a look at BCl3, boron trichloride here. And this one, boron has 3 valence electrons, so these chlorine atoms are going to be as far apart as they can. So, my drawing, when we draw them on the board or in paper, we don't always draw them exactly the way they look. And you can see here, this is more, it should be more a 3, kind of a triangular shape thing. This is known as trigonal, and they didn't write it that way, but it's called trigonal planar. So when you get these, they tend to be what we call trigonal planar. Planar, in other words, they would lay flat, but they would be in a triangle. And the angle between these is 120 degrees, because that's as far apart as you can. You got 360 divided by 3, you're going to get 120 degrees. Alright, our next one is if we've got a central atom like carbon and 4 hydrogens around it. So this would be methane. And when you do that, and this is how we would draw it on paper, it would look like that. But you need to understand that this is going to be a 3-dimensional thing, and you can actually get them a little bit farther away than 90 degrees. You can get 109.5 degrees in what's known as a tetrahedral shape. And so it looks more like this. This is not, 90 degrees. It's more like a pyramid type shape. That's known as tetrahedral, and like I said, they're 109.5 degrees apart between those angles, and that's the farthest you can get anything apart when you have 4 in 3-dimensional space. Most time you think 2-dimensional space, then it'd be 90 degrees, but in 3-dimensional space, it's 109.5. Alright, so let's talk about a central atom with 5 pairs. Actually, let's talk about PCl3, which just has 3, and you can see that we've got phosphorus, we've got our chlorines, and we've got an extra pair of electrons up here that are forcing these away. If these were not here, this would be a trigonal planar one. But because they are here, they force it down, and it now becomes more what's known as pyramidal. So it looks more like a pyramid. It's going to kind of stand up, and you can see how these are kind of coming down. It's going to this atom is actually going to be above the plane of these down here, and this is where the electronic configuration is tetrahedral. You've got 1, 2, 3, 4. You've got a tetrahedral shape, but the molecular shape, what we would see as the atoms, is pyramidal. Okay, so pyramidal for that one. And if we go with PCl5, you remember we've got these 2 extra electrons. They can be promoted, and they can share. Now we get kind of another type of shape. You get this one where you've got these that are 120 degrees apart, kind of in a plane, and then you've got these that go up and down. This is known as trigonal bipyramidal. Okay, so you've got this part, like I said, this would be planar. If you just took the top and the bottom part off, that would just be flat. It'd be the trigonal planar, but you've got these atoms going top and bottom. All right, here's another example. Let's go with SF2, and we've got these unshared pairs of electrons. So once again, if we were talking about the electronic, that would be tetrahedral. Okay, but we're not going to talk about that as far as the molecular, as far as the shape. And so we get this molecule that, these are forced down because these cells take up space. They force these things away. In fact, those electrons that are unshared are actually a little bit stronger than the ones that are. And so they'll force it down just a little bit closer. And you can see in between here, you've got an angle of 98 degrees. This is usually called bent or angular. I think the more common, or the more term that our book talks about is angular. I've always heard of it as bent. And if we go to SF6, now this has got 6 in there, and you can see that these 4 are kind of on the same plane, and these would be 90 degrees apart. And then you've got the ones that are up and down, so it's going to be like that. This is known as octahedral, and it's because you can put like 8 triangles around. If you drew triangles around all those things, you get 8 of them around there. So that's an octahedral shape. So here's just kind of a review of a lot of the common shapes that you're going to see. You should be familiar with these. You should be able to look at molecules and knowing where the electrons are, knowing where the valence electrons are, you should be able to figure out the shape of these particular things. But we've got linear, that's pretty easy, straight line. Anytime you have just 2, that's always going to be linear. And when we get most of these, will have 3 or more. Okay, bent. This would be like water. H2O is bent. The SF2 was bent. Trigonal planar, these all lay in a plane, and you get kind of that triangular shape. And then trigonal pyramidal, where it's not in a plane. Then you have square planar. Okay, that would be, if you kind of recall our octahedral one, if we took these off, but we still had electrons there, you would get a square planar. Tetrahedral, this is a very common one when you have 4 bonds. Carbon does this quite often. And trigonal bipyramidal, where you've got 5 different things on there. And octahedral, where you have 6. Be familiar with these different shapes. And that is the end.